Hi students, let us discuss one more topic. It is very easy and simple topic, that is bond angle. See, we can't calculate the exact bond angle, right? That is by experimentally we will be doing. But when we go for the comparisons with respect to the bond angle, which is having greater bond angle, which is having lesser bond angle, arranged in the order, means you can easily do that. See, the angle between two bonds. See, this is one bond and this is one bond. This is the central atom. The angle found between the two bonds, it is called as bond angle. The steps you should follow to recognize which is having more bond angle, which is having lesser bond angle. The order you can find out easily. First condition is you should check the hybridization of the central atom. I think you are good at finding out the hybridization of the central atom. Suppose if it is sp3 hybridization, the angle is 109 degrees 28 minutes. Shape is tetrahedral. This is the structure. If the hybridization is sp2, the angle is 120 and the shape is trigonal planar, you will be having like this structure. And if it is sp, the structure will be linear and the angle is 180. So when there is the hybridization, by seeing the hybridization you can easily find out. If it is sp hybridization, the angle is very higher. If it is sp2, 120. If it is sp3, 109 degrees 28 minutes. This is first condition. If both after checking this also, by using this content, if you are unable to classify, both are having sp3 hybridization only, then what you will do, or both are having sp2 or both are having sp hybridization, then go for this. If hybridization is same, then check the lone pair electrons on the central atom. Okay, I think you know the lone pairs. What is meant by lone pair? The electrons in the valency shell of an atom which does not involve in bonding. Okay, those are called as the lone pair electrons, or the electrons present in the valency shell of an atom which are already paired. Those are called as lone pair. If you check the lone pair on the central atom, more the number of lone pairs on the central atom, lesser will be the bond angle. Why? Because due to more repulsions. Central atom, more repulsions will be, what happens? So that the bond angle will be lesser. So if hybridization is same, then check the lone pair on the central atom. If more is the number of lone pairs on the central atom, what happens to the bond angle? The bond angle decreases. This is the second condition. First condition is checking hybridization. Second condition is checking lone pair electrons on the central atom. So lone pair on the central atom is more, bond angle will be lesser. Right. If that is also same, if hybridization and lone pairs on the central atom are same, then check. First condition is, you are having two rules in this. Electronegativity of the central atom. If electronegativity of central atom is greater, bond angle will be greater. If hybridization is same, lone pairs on the central atom is same, then go for the third one. Check the electronegativity. If electronegativity of the central atom is more, bond angle will be more. This is for central atom. If that is also same, now see, if you are checking the central atom, the surrounding atom should be the same thing. Okay. Next condition is, if the central atom is same, surrounding atoms are different. See, first condition is, you are checking the electronegativity of the central atom. If you are checking the central atom electronegativity, means whatever the atoms that are linked for the central atom should be the same. Okay. So if electronegativity of the central atom is greater, bond angle will be greater. Next, you check the central, if central atom is same, if surrounding atoms are different, then check the electronegativity of the surrounding atoms. If the electronegativity of the surrounding atom is greater, bond angle will be lesser. So these two are opposite. Okay, this is the way. So electronegativity of the central atom is greater, bond angle is greater. Electronegativity of the surrounding atoms is greater, bond angle will be lesser. Okay, these are the rules that you should remember to find out the bond angle. In clear, we will be having why that angle is greater, why that angle is lower. We can identify that. See, while doing problems, we will be telling BeCl2, BCl3, CCl4. Find out which is having the greater bond angle. This is the question. So, first condition is first find out the hybridization. BeCl2. BeCl2 will be beryllium is second group. It is having two electrons. So, chlorine 1, hybridization will be 2. So, it is sp hybridization. BCl3. If you find out it is sp2, CCl4, it is sp3. So, sp is 180 degrees, sp2 is 120, sp3 is 109 degrees 28 minutes. So, BeCl2 will be having greater bond angle compared to BCl3, compared to CCl4. Next condition is NO2 plus as well as NO2 minus, which is having greater bond angle. So, see, if you go for the hybridization, this is sp and this is sp2. You can easily find out by seeing the hybridization only. Okay. Next, so which one? NO2 plus will be having greater bond angle compared to NO2 minus. Next it is CH4, NH3, H2O. First condition is hybridization. CH4 hybridization is sp3, NH3 is Hp3. Next this one is sp3. Oh God, all are same. Right? So what is our next condition? If bond angles are same, go for the checking the lone pair of electrons. See, CH4 is having how many lone pairs? So bond pairs plus lone pair. It is having 4 plus 0. So no lone pair, 0 here. Here NH3 you are having one lone pair, and H2O you are having two lone pairs. So greater the number of lone pairs, lesser will be the bond angle. So this one will be having the lesser bond angle compared to NH3. This one will be having lesser bond angle compared to CH4. Clear? Now SO3 and SO2. If you check the hybridization, this is sp2, then this is the sp2. Next, if you check the lone pair here, it is 0. And if you check the here, see SO3 structure is this one, SO2 structure is this one. SO3 structure is this, SO2 structure is this. So one lone pair is present, more the lone pairs on the central atom, lesser the bond angle. So SO3 will be having greater bond angle compared to the SO2. And this is the work for you students. You remember this, NO2 bond angle is 132. You should remember this one comes in the middle. So these are the questions for your homework. NO3 minus, NO2 minus, NO2 plus, NO2, NH4 plus, NH3, NH2 minus. Okay, NH3, PH3, ASH3, SBH3. Next it is H2O, H2S, H2SE, H2TE. These are the work for you with respect to bond angles. You do that. And let us take one more example. COF2, COCl2, COBr2, COI2. So if you see hybridization, all are sp2 only. Next, check the lone pairs on the central atom. See lone pair on this central carbon, nothing, you have all the zeros. Go for the central atom. Surrounding atoms are different, central atoms electronegativity. You check if you see this, central atom is same, surrounding atoms are different. So central atom also you can see. Check the surrounding atoms electronegativity. So this one fluorine, chlorine, bromine, iodine. Okay, more is the electronegativity of that one, lesser will be the bond angle. Okay, surrounding atoms, see this is the fourth point. This is what we have learnt here. Surrounding atoms electronegativity is more, lesser will be the bond angle. Okay, right. See here, surrounding atom is fluorine, chlorine, bromine, iodine. Okay, fluorine, chlorine, bromine, iodine. So surrounding atom electronegativity, this one is more. So bond angle will be less. So COF2 will be lesser compared to COCl2, compared to COBr2, COI2. Clear students? In the same pattern you go for this SOF2, SOCl2, SOBr2, SOI2. Okay, this is accepted 99%. Whatever the rules you are talking, I have said, it is applicable for the all. That is maximum 99.9%. But there are exceptions. Suppose if you take the molecule like H2O as well as OCl2. See, if you see H2O, this will be in the pattern. OCl2, this will be in this pattern. See, central atom is same. Hybridization, if you go for the hybridization is same. Central atom is same. Number of lone pairs on the central atom is same. First condition is hybridization. Second condition is lone pair on the central atom. Here you are having 2, here also you are having 2. This is sp3 hybridization, this is sp3 hybridization. Next to go for the what? Central atom electronegativity. The central atom is also same. Next going for the surrounding electronegativity. Here hydrogen is there, here chlorine is there. Which will be having higher electronegativity? This one will be having higher electronegativity. So among hydrogen and chlorine, chlorine will be having higher electronegativity. Surrounding atoms electronegativity is higher means what will be the bond angle? Bond angle should be lesser. But what happened here? But it is greater. Why it is greater so? Why means here the shape chlorine is bulky in size, so that what happens? The repulsions will exist so that the bond angle will become greater. So this is an exception, student. H2O as well as OCl2. In the same way, you are having one more exception like H2O, CH3, CO, CH3, CH3, OCH3, C2H5O, C2H5. Same reason. So hybridization is same. Lone pairs on the central atom is same. Central atom is same, and it depends upon the electronegativity of the surrounding atoms. Surrounding atoms are hydrogen, here CH3, here C2H5, which is having the bigger size. This one is having the bigger size, so that it will be having greater bond angle compared to CH3 compared to hydrogen. This is the information maximum what you can expect with respect to bond angle, students. Have a nice day. Thank you. Bye bye.